So in this video, what I'm going to explain is something about the linear programming algorithm. Okay, the algorithm is really simple, but before learning about this algorithm, it is good to know some of the fundamentals or maybe some of the jargons involved in this algorithm. So let's see the simplest one. Let's see how to write a linear equation. This is something you must have learned in the year one. Actually, this algorithm involves maybe 3 to 4 steps. It's very easy to implement. Mostly we use it for optimization. So first let's see some of the mathematics, and then once you understand the mathematics, then it's easy to understand about the algorithm. And once you know the algorithm, then you can figure it out what type of problem can be solved using this particular algorithm. Yeah? So let's see how to write a linear equation. This is something you should know by this time. So x plus y, this is one example of a linear expression. This is something that looks similar to y is equal to mx plus c. And then another type of linear equation is something called as x minus y equal to 1. This is another type of linear expression. So both of these equations look similar to y is equal to mx plus c. And now we have to know something which is called as, this is something you must be familiar. So I will tell something which is called as linear inequations. Linear inequations. So how do they look like, or how do they read like, or how we write it in a mathematical format? So one example is, say, x plus 2 greater than or equal to 4. This is one example. You have something symbols like less than, sorry, greater than, less than, greater than or equal to, or less than or equal to. So if you see some of these symbols, then this is something we can call it as a linear inequation. So another example is y plus 4 greater than or equal to 10. This is one example. Another example is 2x maybe plus y greater than or equal to 4. Another example is 3x plus y less than or equal to 4. Or another example is 3x plus y greater than or equal to 4. Similarly, this one, 2x plus y is equal to greater than equal to 4. So this is these equations which I wrote here. This is something you can call it as linear inequations. So before going into algorithm, we will learn few more concepts that you need to know. So what are these concepts? Let's try to convert or represent these equations, these linear equations, in a graphical format, or how to plot these equations graphically. So how do you explain x plus 2 greater than equal or equal to 4? How do you write that in a graph, how do you show them in a graph paper? So let's call this as a graphical method for the moment. So let's take one equation, say x plus 4y greater than 8, and another one 3x plus 2y less than equal to 6. So how do you show this graphically? So let's say show these expressions graphically. So this can be a 2-mark problem in the final exam. So for this, to show them graphically, first you need to convert inequalities into equality. So what do I mean by that? So convert inequality into equality. So what do I mean by that? So x plus 4y greater than 8. So this is nothing but a linear inequation. So write it into your linear equation. So sorry, this is a linear inequation. So write it into a linear equation. So x plus 4y that's equal to 8. So now make a table using this function x plus 4y equal to 8. So how do you plot? So what we are going to do is we're going to plot x plus 4y is equal to 8. So that's what you're going to do. So keep x and y. So create a table. So I'll put x is equal to 0. What's the value of y? When y is equal to 0, what's the value of x? So if x is equal to 0, 4y equal to 8, y is equal to 2. So y is equal to 2. So when y is equal to 0, x is equal to 8. So x is equal to 8. So let's plot this one in a graph paper. So let's create some rough plot. 2, 4, 6, 8. 2, 4, 6, and 8. So what values do you have? So we have 0, comma 2. So x is equal to 0, 0, comma 2. That point is 0, this is 0, comma 2. And then x is equal to 8, y is equal to 0. So that's here, 8, comma 0. Just connect these 2 points. So anything that lies on this line, so that should be x plus 4y equal to 8. So any value that lie on this line should follow this equation, x plus 4y plus 8. So now we go to this linear inequation. So x plus 4y greater than 8. So where this region lie in this graph? So to know that, let's substitute. Take this point as a reference point, 0, comma 0. So let's substitute x 0 plus 4 of 0. Is it greater than 8? 0 greater than 8. So this is not true. So which means false. So this means, so any value that lie above this line, so that should be, so how do you show that? So anything that lies above this straight line, this assumption of x plus 4y greater than 8 should hold true. And below this region, x plus 4y should be, it's not greater than 8. So that's the meaning of this. So what we did is we converted the linear inequation into linear equation, and then we try to make a plot. So where this line or the equation of line on a xy graph, and then we try to find the conditions where x plus 4y is greater than 8. So x plus 4y should be greater than 8, anything on the above this line. So you put a point here, and then you get the corresponding x and y, and if you substitute this value in this equation, x plus 4y, that value should be greater than 8. So these are some basic rules that we are learning. Still, we are not going into the algorithm itself. So this is something you should know. If you know some of the basic rules, then you can easily learn the algorithm. So let's go to the second equation. This is just to practice. So 3x plus 2y less than 6. So do the same rules. So let's convert this linear inequation into linear equation. 3x plus 2 is equal to 6. So now make a table. X is equal to 0, y is equal to 0. When x is equal to, this is 2y. So when x is equal to 0, y is equal to 3. When y is equal to 0, 3, x is equal to 6, that should be equal to 2 here. So just plot this equation. So let's plot. So 1, 2, 3, 1, 2, 3. So we have this equation 0, comma 3. So 0, comma 3 is somewhere here, and then 2, comma 0 is somewhere here. So we're trying to plot this value 0, comma 3, 2, comma 0. So just to connect these two lines, that's the equation of line. So this line, any value that lies on this line should be follow this equation, 3x plus 2y equal to 6. So now we need to take the linear inequation, which is 3x plus 2y. So how do you find that? So let's take a reference point 0, comma 0. So 3 into 0 plus 2 into 0 equal to 0, which is less than 6. So which means this is true. So what does that mean? So every value that lie below this line, any point below this line, if you substitute in that equation, that should give the result something less than 6. So in the shaded region, all this shaded region, this equation holds true. 3x plus 2y should be less than 6. So these are some basic rules that we learned. So this should be enough to learn the linear programming algorithm. It's a very simple algorithm. So before going into the algorithm itself, I'm going to solve a few more things. So now let's consider a system of a linear inequations together with some constraints. So let's say we have a system of linear inequations. So x plus y less than 6, x greater than 1, y greater than 1. So these equations are just to help you to get familiarized with some of the steps involved in the linear programming algorithm. Yeah? So let's do this. So what's the rule here? So let's take one by one. So let's take x plus y equal to 6. We write it into a linear equation. X is equal to 1, y is equal to 1. So make a table x, y, 0, y is equal to 0. So when x is equal to 0, y is equal to 6. When y is equal to 0, x is equal to 6. So plot it. Let's say 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Let's say 6 is somewhere around here. So 0, 6 is here. This point is 6, 0. Just draw a straight line. So anything that lies on this particular line, that should follow this equation, x plus y equal to 6. So now we have to plot this one. So what is x is equal to? X is equal to 1. So which means for all values of y, x is equal to 1. So that is somewhere around here. And then y is greater than equal. So y is equal to 1. So that is for all values of x, y is equal to 1. So that is something around here. So this is y is equal to 1 and this line is x is equal to 1. So now we have to find some of the conditions. So x plus y less than 6. So let's take x is equal to 0, y is equal to 0. So 0 is less than 6, which is true. So which means every point below this line, if you take the x and y value, corresponding x and y value, and if you substitute in this expression, that value should be equal to less than 6. Yeah, so which means all the shaded region, this rule or this equation holds true. And now where is x greater than 1? So x greater than 1 is everything or after this line. So that's x greater than 1. For y greater than 1, so every point above this line will be y greater than 1. So now we have to find a common point. So common region where all the conditions hold true. So find the common region where all these three conditions hold true. So that is somewhere around here. So within this region, within this shaded region, all the conditions hold true. X plus y less than equal to 6, x greater than equal to 1, y greater than equal to 1. So where all conditions are met. So I think this is almost ready to learn the linear programming algorithm. So we will stop here now, and then next we will solve a problem where using a linear programming algorithm where you may need to implement some of the steps that you learned. So for the moment we didn't enter into the algorithm. All we did is we know how to take a equation, linear equation, and then we can convert it into a linear equation, and then we applied some of the conditions so that we can get the equation of the straight line of the this is a linear equation. So whatever the value you substitute, it's going to produce a straight line. And then we also consider some other conditions where we have some constraints, and we also try to make a plot. We also try to identify the region where this expression holds true for condition something like 3x plus 2y less than 6, so something like a non-linear inequation. Yeah, so this is a buzzword that we'll learn today, so keep this in the mind. So these are the algorithms. So we need to convert a linear equation into linear inequation into linear equation, and then we try to plot them. We try to identify some region where these equations hold true, and then when we have more than one constraint, we also still try to plot all the constraints on a piece of graph paper, and then we try to find the region where each of these linear inequations and or the linear equations hold true, and then we try to find a common region where all these three conditions meet, yeah, or becomes valid. So that's what we learned until now. So we will use this knowledge to solve a problem where we need to implement a linear programming algorithm, which is really important to solve many of the chemical engineering problems that we are going to encounter.